Hi friends, welcome to biologyexamsforyou.com. Today the topic of our discussion is classification of carbohydrates. We'll be discussing what are carbohydrates, classification based on number of monomers, classification based on functional group, based on number of carbon atoms, and based on rotation. So we'll be discussing in detail the classification, different types of classification of carbohydrates within 5 to 10 minutes. Let's begin with the definition. What are carbohydrates? Let's take an example. So this is glucose, the most common carbohydrate, having a general formula C6H12O6. So with this formula, let us define glucose. Here you can see there are many hydroxyl group, or the functional group in glucose. The first one is hydroxyl group. Then there is an aldehyde group, CHO or aldehyde group. So this is glucose. So carbohydrate can be defined as a polyhydroxy aldehyde. Let's take one more example. So this is fructose. It is having the same formula, C6H12O6, an isomer. Here the functional group is ketone. Now we can define carbohydrate as biomolecules which are polyhydroxy aldehydes or ketones made up of carbon, hydrogen and oxygen, often in the ratio 1:2:1. If the carbohydrate is with aldehyde group, then it is called as aldose, where the carbohydrate with ketone group is called as the ketose. Now moving into the classification of carbohydrate. First classification is based on number of carbohydrate units. First one is monosaccharide. We have discussed glucose. So this is glucose, C6H12O6. And this is a monomeric unit, or the basic building block. That means on hydrolysis, glucose will remain as glucose. It cannot be further divided. Or monosaccharides are simplest carbohydrate units or monomer that cannot be hydrolyzed further. It's having a general formula CH2ON, or carbon, hydrogen and oxygen in the ratio 1:2:1, and the minimum number of carbon atom is 3, or the simplest monomer is glyceraldehyde, a 3-carbon monosaccharide, which is an aldose, and the ketose is dihydroxyacetone, which is a ketose, simplest ketose with 3 carbon. The second type is the disaccharide. As the word indicates, di means 2, saccharide means sugar unit. So here disaccharide on hydrolysis, it will yield 2 monosaccharide units. So this is a disaccharide that is formed by the bond which is called as glycosidic bond. We have given a short video on glycosidic bond. You can refer that for more on glycosidic bond. So this is the 2 monosaccharide unit. Let's take an example. So this is glucose. Glucose plus glucose, that forms maltose, which is a disaccharide that is made up of 2 glucose units linked by glycosidic bond. This bond is called as glycosidic bond. So the bond is called as the glycosidic bond. Now the third type is oligosaccharide. Oligosaccharides are often carbohydrates usually made up of 3 to 10 monosaccharide units joined by glycosidic bond. Example is trisaccharide raffinose, and there are many examples. And finally, polysaccharide, or the most complex carbohydrates made up of hundreds of monosaccharide units that is connected by glycosidic bond. Classical examples include cellulose, glycogen, etc. There are 2 types basically, structural polysaccharides and storage polysaccharide. Structural polysaccharide means that is imparting something to the structure of the organism like cellulose, chitin, etc. Whereas storage polysaccharide is a reserve food in organisms like starch in plants, glycogen in animals, etc. All are polysaccharides made up of thousands of monosaccharide units joined by glycosidic bond. So this is a polysaccharide. You can see hundreds of monosaccharide units, glucose units that is joined by glycosidic bond, and this is starch, a polysaccharide. Now the second type of classification, that is classification of carbohydrates, that is based on functional group. So we have already discussed that aldoses are carbohydrates with aldehyde or CHO functional group, whereas ketoses are carbohydrates with ketone or CO functional group. We have already discussed that topic in the first slide itself. So the aldoses examples include glyceraldehyde, which is the simplest aldose, 3-carbon compound. Then there is ribose. Then there is glucose. Then ketoses, the simplest one is dihydroxyacetone. Then 5-carbon ribulose and 6-carbon fructose. These are some examples of aldoses and ketoses. Now the third classification, that is based on number of carbon atoms. Here in glyceraldehyde, which is the simplest monosaccharide, it is having 3 carbon. Therefore, it is called as triose. This is the group is CHO or aldehyde group. Therefore, it is an aldotriose. Whereas here also there is 3 carbon, which is the simplest ketose, that is dihydroxyacetone, which is called as ketotriose. Then there is tetrose. This is having 4 carbon, 1, 2, 3, 4, which is example is erythrose. Then pentose, the classical example is ribose, present in DNA, 1, 2, 3, 4, 5. And glucose, as we have already discussed, it is having 6 carbon, C6H12O6. So glucose can be called as aldohexose, as it is having an aldehyde group and it is having 6 carbon. So this is a classification based on number of carbon atoms. And finally, based on rotation, carbohydrates can be classified as dextro and levo. So this is the simplest carbohydrate, and this classification is primarily based on stereochemistry of the highest numbered chiral carbon of the Fischer projection. If the hydroxyl group is oriented towards right like this, then it is dextro. If the hydroxyl group of the highest numbered chiral carbon is oriented towards left, then it is levo. Dextro in Latin means right, whereas levo means left. So let's take one more example to understand the highest numbered chiral carbon. Chiral carbon means that carbon is bonded by 4 different groups. So this example, you can see this 5th carbon is a carbon that is bonded by 4 different groups, and this is the highest chiral carbon. Here this OH group is oriented towards right side, that is why this is called as T-glucose. In the case of L-glucose, the highest numbered chiral carbon, the OH group is oriented towards left side, that is why it is called as L-glucose. Normally, naturally occurring carbohydrates are of D configuration, where OH group is oriented towards right side. So these are the different types of classification of carbohydrates. Hope you are following me. Thank you so much for your support. You are with biologyexamsforyou.com. Please subscribe, share and like.